Hello everybody, welcome into another lesson. So today we are going to talk about double angle formulas for trig functions. So here you have the sine of 2x. So if you have 2 times an angle, the sine of that angle, it's going to be equal to 2 times the sine of 1x times the cosine of 1x. If you're going to have the cosine of 2x, that's going to be the cosine squared of x minus the sine squared of x. And then the tangent of 2x equals 2 times the tangent of x divided by 1 minus the tangent squared of x. And you could easily get the reciprocal functions for these by just taking the reciprocal. So that would not be so bad. So we're going to do some exercises here to start. Let me set up our triangle. And let's see what they give us here. So we have a 3, 4, 5 right triangle. First, we're going to be asked to find the cosine of 2 theta. So here is your angle theta. So we're going to find the cosine of 2 theta. We might want to then, first before we even try to find anything, apply the formula for the double angle of a cosine. That would be the same as the cosine squared of theta minus the sine squared of theta, which all we have to do now is put these values in. So what is the cosine of theta in this case? That would be 4 over 5. So you would take 4 over 5, square that, minus, alright, so what is the sine of theta? That's 3/5. You're going to square that. Well, that's just going to equal 16/25 minus 9/25, which should end up giving you a value of 7/25. So in this case, the cosine of 2 theta would be equal to 7/25. And then if you want to find the secant of 2 theta, that's also pretty easy because the secant is simply the reciprocal of the cosine. Just take the reciprocal of 7/25, you'll end up getting 25/7. That would end up being the value of your secant of 2 theta. It would be 25/7. Alright, let's go to the sine of 2 theta. So let's find the sine of 2 theta. That is going to, of course, be equal to, let's use our sine of 2x formula, so that would be 2 times the sine of theta times the cosine of theta. Now all we have to do is plug in these values, so take 2 times what is the sine of theta, that's 3/5, times the cosine of theta, that's 4/5. So 2 times 3 is 6 times 4 is 24. So your sine of 2 theta should be 24/25. And then if you were asked to find the cosecant of 2 theta, well, we know cosecant is the reciprocal of the sine, so just take the reciprocal of 24/25 and you would end up getting 25/24 for the cosecant of 2 theta. And then we can find the tangent of 2 theta next. So to find the tangent of 2 theta, we can apply our tangent of 2x formula. That's going to equal 2 times the tangent of theta all over 1 minus the tangent squared of theta. Alright, so let's plug in the values here. So 2 times what is the tangent of theta? That would be 3/4 all over 1 minus that tangent of theta is 3/4. Well, that would be 3/4 to the second power this time. So let's simplify the numerator and denominator. You would end up getting 3/2 all over 1 minus 9/16, which would end up giving you 3/2 all over 7/16, which, since you have a complex fraction, let's go ahead and invert and multiply. This would be the same as 3/2 times 16/7, which would turn into 3 times 8 all over 7, so you should end up getting 24/7. So the tangent of 2 theta is going to be 24/7, and then if you were asked to find the cotangent of 2 theta, that's also pretty easy. Just take the reciprocal of 24/7. You would end up getting 7/24. So those are that's a basic first quadrant triangle example. Let's go on to some other triangles here. All right, so we are given that the cosine of angle U equals -2/7. This is going to be where pi over 2 is less than angle U, which is less than pi. Well, pi over 2 less than U less than pi, well, we're actually going to find, we're going to find the sine, cosine, and tangent of 2U. So where pi over 2 is less than an angle, and that angle is less than pi, that's going to be in quadrant 2. So that would end up being in quadrant 2. So they give you that the cosine of U equals -2/7, so that's going to be adjacent over hypotenuse, and of course your x is negative in the second quadrant, so that makes sense. Well, before we even attempt to find any values here, we should use Pythagorean theorem and solve for the missing side. So if I take -2 squared plus, let's call that y squared, or y rather, excuse me, plus y squared, set that equal to 7 squared, well, we would end up getting that, let's see, we'd have 4 plus y squared would equal 49, which means y squared equals 45. And since we're in the second quadrant, your y is positive, which would mean your sine's positive, so we're going to take the positive square root of 45. You'll get that y equals square root of 45 is the square root of 9 times 5, so that would be 3 times the square root of 5. So we should end up then getting that the missing side is 3 times the square root of 5. Okay. From here we can find the 3 main trig values for, let's start with the sine of 2u. So let's apply our double angle formula for the sine function. That would be 2 times the sine of u times the cosine of u. So 2 times, now what is the sine of u? That would be 3 times the square root of 5 all over 7 times the cosine of u. That was -2/7. So that should just end up giving you a value of let's see, 2 times 3 is 6, times negative 2 is negative 12, so you should end up getting negative 12 times the square root of 5 over 49 for the sine of 2u. You'll end up getting negative 12 times the square root of 5 over 49 for the sine of 2u. Alright, let's do the cosine of 2u. So we're going to do the cosine of 2u. So we can apply the double angle formula for the cosine function. That would end up being the cosine squared of u minus the sine squared of u. Now let's just input our values. What's the cosine of u? That's negative 2/7, but we need to raise that to the second power. Then minus, what's the sine of u? That's 3 times the square root of 5 over 7, but we got to raise that to the second power. Okay, so negative 2/7 raised to the second power is going to be 4/49 minus 3 times the square root of 5 over 7 raised to the second power. That's going to be 45/49. So the answer in the end should end up being negative 41/49. So you should get that the cosine of 2u would equal negative 41/49. And then, of course, we can do the tangent of 2u. So the tangent of 2u, we can apply the double angle formula for the tangent function. So that would be 2 times the tangent of u all over 1 minus the tangent squared of u. So let's put in the tangent of u. So that would be 2 times, the tangent of u is 3 times the square root of 5 over negative 2, then over 1 minus that tangent squared of u. So that would be 3 times the square root of 5 over negative 2, but you square that. So let me move over here. So in the numerator, that's going to simplify into negative 3 times the square root of 5. All over the denominator would be 1 minus 45/4. Okay, so let's simplify the denominator even more. You'll end up having negative 3 times the square root of 5 over negative 41/4. So now you just have a complex fraction. We just invert and multiply. So this should be negative 3 times the square root of 5 over 1 times 4 over negative 41. Which in the end should end up giving you positive 12 times the square root of 5 over 41. That would be the value of the tangent of 2u, positive 12 times the square root of 5 over 41. All right. Let's go for a third quadrant triangle. I like to at least do one in each quadrant. The very first example we did was in obviously in quadrant 1. We just got through quadrant 2. Let's do a quadrant 3. Okay, so I found one. We have that the tangent of u equals 1/2, and u is where pi is less than u, which is less than 3 pi over 2. Well, when pi is less than angle u and u is less than 3 pi over 2, that's describing the third quadrant. So This is going to be in quadrant 3. So here's angle U. Alright, so the tangent equals 1/2, but keep in mind we're in the third quadrant. So what's true about the third quadrant? Both your x and y values are negative, so both your cosine and sine are negative. So really this should end up being, the first two sides should have lengths of -1 and -2, simply for the fact that we're in the third quadrant. Now we can use Pythagorean theorem to solve for the hypotenuse. We'll call that side C. So take that -1 squared plus the -2 squared, set that equal to C squared. You should end up getting 1 plus 4 equals C squared. C squared equals 5. Well, the hypotenuse is always positive, so C would be equal to positive square root of 5. So now we found the hypotenuse. That would be the square root of 5. Alright. Now we're going to do like we did in the last exercise. We're going to start with the sine of 2u. Well, let's apply the double angle formula for the sine function. So that would be 2 times the sine of u times the cosine of u. Now we just got to plug in values. So take 2 times, now what is the value of the sine of u? That would end up being -1 over the square root of 5. And actually it's going to work out nicely for once if we don't rationalize the denominator. You'll see in just a minute. And then the cosine is -2 over the square root of 5. And it's going to make sense here why I didn't rationalize the denominator. So 2 times -1 is -2 times -2. That's positive 4 over your denominator just turns into a 5. So you just it rationalized itself by leaving it alone. So the sine of 2u would end up being positive 4/5. Okay. So there's the sine of 2u. Let's find the cosine of 2u. Alright, so let's see. Let's apply the double angle formula for the cosine function. That would be the cosine squared of u minus the sine squared of u. Alright, so let's apply these values. The cosine of u is -2 over the square root of 5. But we have to square that. Minus, what is the sine of u? That's -1 over the square root of 5. But we got to square that. So you'll end up getting 4/5 minus 1/5. Which should mean that your cosine of 2u would end up being 3/5. So the cosine of 2u ends up being positive 3/5. And last but not least, let's find the tangent of 2u. Alright, so there's the tangent of 2u. So let's see, apply the double angle formula for the tangent function. That should be 2 times the tangent of u all over 1 minus the tangent squared of u. This one isn't going to be bad at all. So let's apply these values. 2 times what is the tangent of u? That would actually be positive 1/2. All over 1 minus that 1/2 squared. So this is going to simplify into simply 1 over 1 minus 1/4, which would end up being 1 over 3/4, which would be 4/3. So the tangent of 2u ends up being positive 4/3. And you guessed it, we're about to move on to a fourth quadrant triangle. We certainly are. Alright, so we have that the cotangent of u equals -6. They give you that 3 pi over 2 is less than u, which is less than 2 pi. Well, if 3 pi over 2 is less than angle u, which is less than 2 pi, that's describing quadrant 4. So it's very important to identify what quadrant you're in. Now, let's deal with this angle u. They tell you that the cotangent of angle u is -6. Cotangent, of course, is adjacent over opposite. Well, what's true about the fourth quadrant? Your cosine's positive, but your sine is negative. So your angle u is actually going to be up here because your sine is negative, so that side would have to be -6, and then your x length would have to be 1. It would probably be easy for you to think that it would just be, well, I mean, you could end up arguing it would be 6 over -1, but that would put you in the second quadrant. So that's why it's important to identify your lengths correctly, so you set yourself up for success. And of course, we don't know the hypotenuse. We'll call that side C. So let's use Pythagorean theorem. You take 1 squared plus that -6 squared. That'll be C squared. So 1 plus 36 equals C squared. C squared equals 37, and your hypotenuse is always going to be positive, so that hypotenuse has a length of the square root of 37. So now we know the length of the hypotenuse. And let's go ahead and find the double angles for the sine, cosine, and tangent. So let's start with the sine of 2u. That equals 2 times the sine of u times the cosine of u. Now we just got to plug these values in. 2 times what is the sine of u? That's opposite over hypotenuse, so that would be 1 over the square root of 37 times what's the cosine of u? That's -6 over the square root of 37. So when you simplify this, you should end up getting -12 over 37. So that means that the sine of 2u would end up being -12 over 37. All right. Let's do the cosine of 2u. So let's input our formulas here. And now let's do the cosine of 2u. So this would be equal to the cosine squared of u minus the sine squared of u. Alright, so what's the cosine of u? That's -6 over the square root of 37, but we have to square that. Then minus what's the sine of u? That would be 1 over the square root of 37, but we also got to square that. So this would simplify into 36 over 37 minus 1 over 37, which should give you a value of 35/37. So the cosine of 2u ends up equaling 35 over 37. And then last but not least, let's do the tangent of 2u. So the tangent of 2u, that of course is equal to 2 times the tangent of u all over 1 minus the tangent squared of u. So 2 times what is the tangent of u? That's going to be -1/6 all over 1 minus that negative 1/6 squared. So the numerator would simplify into negative 1/3 all over 1 minus the, let's see, that would end up being 1/36, which would simplify further into negative 1/3 all over 35/36. Complex fraction, invert and multiply, so negative 1/3 times 36 over 35, which should end up giving you negative 12 over 35. So the tangent of 2u should equal negative 12 over 35. Alright, so we've done it with the triangles. Now I got 4 more exercises here where we're going to apply the double angle formula to turn expressions into a double angle formula. So we can even erase the triangle. We're not going to need that for these last 4. But first, let me expand upon the cosine of 2x. Well, okay, so you have cosine squared of x minus sine squared of x. Well, we can use Pythagorean identities to get this in terms of one of the functions also. So if we take cosine squared of x minus sine squared of x, let's say we want to put it in terms of sine. So what is cosine squared using the Pythagorean identity? Well, that's the same as 1 minus the sine squared of x. Then take that minus the sine squared of x. That should simplify into 1 minus 2 times the sine squared of x. So if you wanted the cosine of 2x just in terms of sine, you can also say that it's 1 minus 2 times sine squared of x. And you guessed it, we're about to do this in terms of the cosine. So sine, what's the Pythagorean identity for the sine squared? Well, that's just 1 minus cosine squared. So you would take cosine squared minus the quantity of 1 minus cosine squared of x, which should simplify into cosine squared of x minus 1 plus cosine squared of x, for a final answer of 2 cosine squared of x minus 1. So this should show you that there are 3 ways you can actually express the cosine of 2x. And this is going to come into play for what we're about to do. That's why I did this. But honestly, if you can just remember that the cosine of 2x equals the cosine squared of x minus sine squared of x, and you're good with your basic Pythagorean identities, these next 2 you can easily derive from that. This is just a shortcut for us to help us with what we're about to do. So we're going to simplify the expression in terms of a double angle of a function. So let's say we have 8 times the sine of x cosine of x. How can we rewrite that? Well, isn't 8 the same as 4 times 2? That would be equal to 4 times 2 times the sine of x cosine of x, would it not? Now, if we look at our double angle formulas, what is 2 sine of x cosine of x? That's just the sine of 2x. So this would simplify nicely into 4 times the sine of 2x. So that, yes, that will simplify very nicely into 4 times the sine of 2x. I got 3 more of these, then we're done with the lesson. Okay. Let's say we have 4 times the sine of x cosine of x plus 1. Well, 4 sine of x cosine of x, is that not the same thing as 2 times 2 sine of x cosine of x plus a 1? Well, what is 2 sine of x cosine of x? That's just the sine of 2x, so this would end up simplifying into 2 sine of 2x plus 1. So what you started with, 4 sine of x cosine of x plus 1, is the exact same thing as 2 sine of 2x plus 1. Alright, 2 more. So we have 6 minus 12 sine squared of x. So we got 6 minus 12 sine squared of x. I think first thing we should definitely do is factor out that 6. So this would turn into 6 times 1 minus 2 sine squared of x. And now you're about to see why we just did all that work with the cosine of 2x. Because that 1 minus 2 sine squared of x turns into the cosine of 2x. So this can be rewritten as 6 times the cosine of 2x. So that worked out rather nicely. 6 times the cosine of 2x. I got just one more, then we're done. So we have the cosine of x plus the sine of x. That quantity times the cosine of x minus the sine of x. This one is almost laughable because it definitely looks like the difference of two squares factored, which it turns out it is. You would end up getting the cosine squared of x minus the sine squared of x, better known as the cosine of 2x. So all this factored or got simplified nicely into the cosine of 2x. So the moral of the story with these last 4 exercises we just did is look for ways to simplify expressions. That's going to be especially useful once you get into calculus. Alright, so that's it for this lesson. Next lesson will be not a very short, but a somewhat short lesson on power reducing formulas for trig functions. So I hope everyone has a great day. Take care.